Hey everybody. A while back I mentioned I was going to do an experiment with a Kodak Zi6 camera. Here we're looking at the Kodak Zi6 number 1 as I call it. I have two of these that I regularly have in service. This one over here is just a parts one I have, and I actually have another one that's fully assembled. You can get these things on eBay for like $20 or so. And they're decent cameras for what they are. This one here just happens to have been, this has had a lot of use filming videos for Cube Computer Channel, primarily for Cube Computer Channel, since November 2012. That's when I got this thing. So yeah, almost 4 years of hard use, and it's definitely taken its toll on the camera. The reason why I had to pull this camera out of service is because I'm having an issue with it. Just once in a while it will just lock up, and a lot of times you'll lose the video file. Also, for another example, I'm going to grab me some AA cells. Let's grab some fresh ones just for the heck of it. I'll show you guys something with this thing. I'm starting to have this sort of a problem on the Zi6 number 2. What's going on here is the battery door. Now it looks a little rough now because I already had this open at one point, but let me see if I can sandwich this back down. I don't know if that's going to happen or not, but there we go. You can see how the door is just not staying on there very well. You can see there's a really, really big gap there. What's happened is there's little plastic notches. Oh, there was one. Get you a good focus, you can see better. There was one here. And there was one here. Both had broken. In addition, pop these batteries out. So in addition, okay, batteries should start rolling around, be good. Okay. So in addition, there was one here and it broke. So now all that's left is this one here. That's all that's holding this thing on here. I mean, that's it. That's the only thing. And it's on the verge of breaking because I'm pulling on it too. But that's all that was actually holding this thing on there. Now I'm thinking there's a possibility that just not making a good mating connection could be delivering unstable power to the camera, which could be responsible for the random freeze ups. This thing, in addition, the case has seen so much wear now. You're seeing this broken, where you see where I've had to replace the screen on it. I had to do this when I got the camera. I was totally aware of this when I bought it. The original screen, the clear plastic cover had a big crack in it, and there was a chunk missing out of the center. The LCD was actually okay, but there still was a big crack. So what I had to do was I took the famous needle nose pliers, as I just recently featured, and chewed out a bigger hole. Took the piece off of a DXG 579V that I have for scrap parts, and fitted that on, which also houses a 2.4-inch display, and just fitted it over top of the existing hole. And that's the way it's been for about 4 years. But what's happened here is the threaded holes where the screws thread in here, and I think down here, actually this in here broke. But yeah, what's happened is they've all the threads have all broken, so the whole thing can just be pulled out like so. And you can clearly see through to the other side. Now actually I had this super glued there for the longest time. So anyways, what I'm going to do today is I want to see the feasibility of potentially running a Zi6 on lithium-ion batteries. So we have our positive and negative terminals down here. What I got to do is, since this camera is in a poor state of condition already, so I'm going to see if I can get those out of there. And it looks like I just accidentally disconnected our LCD display. Dadgummit. Kind of knew what's going to end up happening. Let's get the famous needle pliers and see if I can pull these out of here. They should lift right out. Yep, there they go. There's negative. And we'll pull the positive up as well. Okay, there's our positive. Heck, I may as well just go ahead and rip the rest of this off. But yeah, there's like nothing holding it together except super glue. I kid you not. Now you can see exactly what I was referring to inside here. I just took the just broke this up further and managed to fit an LCD inside there. Because what I want to do here is I want to see how the Zi6 can run, if it'll run, on lithium-ion power. So anyways, I've already done some research on the matter, and it looks like we may have a green light for that. Let's go take a look. Okay, everybody, here we're looking at, before I show you a data sheet, let's go and look at the board responsible for intaking power to the camera. This is the original power and speaker and mic PCB, or the daughter board from Zi6 number 1. Because when I got this camera, I simply swapped over the daughter board from a DXG 567V. Yes, they have the exact same daughter board. It's simply referred to as DV567 power. Yes, both these cameras have the exact same one. The thing we have to look at here is, I don't know if you can see it here on this camera, is that little integrated circuit right there. Oh yes, we can get a good focus on that. It's the AAT1415A. Let's go have a look at a data sheet for that. Okay, here's the data sheet for the AAT1415A. It is a 5-channel DC-DC converter with a 2.5 volt LDO. Features the complete pulse width modulation and power control circuitry. Input voltage range 1.5 to 5.5 volts. Low startup voltage 1.2 volts. Independent on-off control for all channels. Internal soft start for all channels. Power OK outputs and overload protection. Adjustable operation frequency with external components ranging from 100 kilohertz to 1 megahertz. Blah, 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 blah. So, you know, the package. Applications: digital still cameras, digital videos. You mean digital video cameras? Okay. PDAs, portable devices. Now, here's a simple schematic of our converter. You can see the power source clearly says lithium-ion or 2 AA battery. The Zi6 has 2 AA's, but it looks like this can in fact be powered off of lithium-ion. You see channel 1, lens motor 4.6 volts, system 3.3 volts, core 1.5 volts, CCD, wow, 12 volts, CCD VL minus 6 volts, and 2.5 volt LDO. So yeah, this thing it performs a similar function to like what you would see take place like in a laptop, for example. You know, your power adapter takes in, you know, it puts in 19.5 volts generally, but a lot of your components run on different voltages like what you would find probably in a desktop computer. Like for example, the hard drive, it usually takes 5 volts. But there are also components in there that take 12 volts. The lithium-ion batteries in most of these newer laptops generally run their voltage, full charge voltage is around 11.1 to 12 volts or so. So this is a DC to DC converter, and it actually steps up some of these voltages. Some of the voltage that comes in, depending on what channel you're dealing with, it'll actually step them up. And here's the pin configuration of that little bitty integrated circuit. See, there you have it. The one thing I'm wondering about is it claims it can take lithium ion or 2 AA's. But 2 AA's together, assuming nominal voltage of a nickel metal hydride cell, which is 1.2 volts, that's 2.4 volts. And let's see, for a single cell lithium ion battery, the nominal voltage is 3.7 or 3.6 depending on the cell. And you generally don't want to take them below 2.8 volts. 3 volts being more of a conservative number. But 2.8 volts, you generally don't want to go below that. And if you really don't want to go down to 2.5 volts or below that. So that's probably the biggest concern that I have here is, it claims to work with either or, but, the Zi6, of course, was designed to take AA's. So, would that mean that the camera's firmware, would it be programmed to, this is a power supply, obviously. It takes in a certain power source and steps it up or steps it down, whatever, and delivers it. Funny enough, my AA's just died, and I had to change out to another set of them. So, anyways, as I mentioned, with this, my concern here is this claims to be compatible with lithium ion or 2 AA battery as a power source, but considering the Zi6 was designed to take 2 AA's as a power source, would the firmware be in control of shutting off the camera when the power source gets below a certain threshold? Or is it actually coded into this? Is it coded into that? Yeah, that's kind of a good question, to be honest with you, because you don't want to hurt your lithium cells by running them down too low. But what's interesting here is it mentions the power source input voltage range is 1.5 to 5.5 volts. So theoretically, you could probably run a Zi6 off of a USB source, USB power. Although if you try to run the camera, if you try to plug in the Zi6's built-in USB port, the USB plug, you plug it into a power source, the camera's not going to work. I've already tried that before numerous times in the past. But you can see here that this data sheet it claims, now you see it says supply voltage. That would be VDD, which is right there. Yeah, so here's the absolute maximum ratings of this thing. If you want to take a look, it says supply voltage VDD value minus 0.3 to positive 6 volts. See, pin voltage 1, blah, 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 blah. Out 1, out 2. And it says the same thing. Pin voltage 2 minus, it's got that minus 0.3 to VDD plus 0.3. Okay, I'm not going to go too much into detail. If you just want to take a look at that, pause the screen for a sec, the video rather. Okay, and look at just look at the operating temperature range, minus 40 degrees C to positive 85. And yeah, I can tell you that my Zi6s have gotten pretty hot inside the weather case on a sunny day. Here we have the electrical characteristics. Let's see, input voltage range. Again, it says minimum 2.6, maximum 5.5. VDD under voltage lockout. Minimum 2.35, typical 2.4, max 2.45. Now these three are definitely too low for a lithium ion cell. VDD under voltage lockout hysteresis 80 millivolts. CH1 minimum startup voltage 1.2, typical, max 1.5. And these are just supply currents. So yeah, let's look at the data sheet. Now we'll go ahead in there and just take a look at things and see what we can figure out here. And I have an old lithium ion cell that's not charging to a full, nowhere near full capacity anymore. If I drastically over discharge that thing, it's not gonna hurt my feelings a bit. I'm just curious to see what happens here. Well, looky here, guys. As I was in the process of wiring in an 18650 battery box just for temporary use, look at what happened here. The freaking negative wire just fell right off the terminal for the on the PCB there. Just fell right off of there. Now this thing had been pulled in and out several times. As I mentioned, this PCB here was originally in the DXG 567V that I got back in 2010. So this thing has had a very long and hard life, I have to say. So I'm heating up the soldering iron so that way we can resolder this back on. There. To see if this is even going to work or not. I don't think we'll have any smoke. That's why I look at that. That's why I looked at the data sheet first. 3.7 volts or 4.2, which is the full charge of a lithium ion, is definitely within the operating range of that DC to DC converter. So we'll just see how this goes once I get this thing fixed. Okay, everybody. I just went ahead and direct soldered this to the positive and negative terminals, of the PCB, essentially right there. I just went and disconnected the remaining wire, which was the positive, and I just went ahead and directly soldered the leads to the battery box to the PCB. I now have the main board reattached. I have an LCD display for one of these. And I went ahead and just temporarily went and put some tape along the back so that way I could rest this wherever I wanted to without having to worry about it making a connection, sorting something out. So our first test will be to see if the camera can power on with 18650s, which I think it should be able to. Just going to grab our two test cells. I got a green Sony 18650, which I think is fully charged, and I got this blue one. I don't know if it's fully charged or not. So we'll go ahead and see. I'm only going to run a single cell to power this. I'm not going to run two in parallel right now anyway. We have on the blue LG cell, we have 3.6, and on the Sony we have 3.78, so it's not exactly fully charged. Now this LG cell, this is one of the ones that came out of my second laptop battery extraction. This one here, it's not charging up to a very high capacity anymore. It only charges up to about maybe 1,000 milliamp hours or so. So if I heavily undervolt this thing, it's not going to be the end of the world. So I guess here goes nothing. And first I'm going to go and secure this. I'm going to try to secure this wire down a little bit more. I feel better when the wires are more secured. That way I wouldn't end up in a situation where the wires are getting brittle and wanting to fall off the pads. Because last thing you ever want to do is short out an 18650. Here in a moment I'll show you exactly why. This happened. This happened a while back actually. Make sure it's good and secure. Grab me a flashlight and we'll take a look at that. Okay everybody. Before I actually start, let me show you what I was talking about previously. Look at this battery box. You see how discolored that is right there? That's the power of an 18650 lithium cell. As you can maybe be able to see, these boxes are incorrectly marked. They're marked as series, but they're actually wired in parallel. So if you connect these in the order shown here, you will essentially be bridging your negative here and your positive over here. You just be doing a loop, or essentially a dead short. This happened back when I first got this these holders. The seller on eBay failed to specify whether they were series or parallel. Luckily I had my finger right here. I was able to get the battery disconnected from this, just in time. Because this actually got red hot. So anyways, yeah. This is why I say you gotta respect this chemistry. So now, I've got everything plugged up. We're gonna start out with just a simple power on test. Provided everything in that data sheet's correct, we shouldn't have any problems here. Alright, power's applied. Let's turn it on. Okay, this looks a lot better. It's asking me to set the time, which I am not going to do. Not right now anyway. What? Whoops. Dang it. And this is going to be kind of difficult, but I'm going to try to show you this thing. Crap. This thing is, you can see the table. You can see there, but there you go. You can see through the viewfinder. And it's funny, apparently I must have formatted the internal memory. Let's go ahead and fill it up. Because when you do the microphone mod as I've done, there's no way you can plug this thing in and get what's off that internal memory. So I just go ahead and make some sort of random recording and fill it up till it quits recording. You see the little icons already lit up. It's going to stop now. Okay, so now with the camera running, let's take a voltage reading of our battery. These these battery boxes do give you easy access to to the terminals, which is both a good and a bad thing. Like for example, if you watched my video of using black hot glue to modify cameras, I used some black hot glue to cover up the end on one of these battery boxes. So our cell is currently at 3.27. So now what we're going to be doing is we're going to load in a 16 gig card. I hope that's enough space. I may have this thing record at 60 frames, just that way it uses more juice and drains the battery faster. So let's go and do that. Okay, I just got this set up in here. Just got it sitting on my desk. I'm going to switch over. Whoops. A little bit of lag. Okay. Switch over to HD 60 FPS. That should work a little bit harder. And we're going to go ahead and start recording. Got a clean 16 gigabyte card loaded in there. Now it's just a matter of waiting to see what it does. I brought it in here so I can monitor it while I work on other things at the computer. I'm gonna bring my multimeter here as well, so that way I can periodically check the voltage of the cell. Now, as I mentioned, this particular LG cell here, it's seen its better days. I haven't had any problems with it getting hot or anything. It's just all of a sudden its capacity degraded down to about, I don't know, 1,000 milliamp hours, while the other two that are still okay will charge up to like they're still holding like 2,000 to 2,200 milliamp hours, which these are rated at, I think, 2,200 milliamp hours. These are LG Chem cells out of an HP pack. And it claims we have a full battery. or do we? Yeah, that's the thing. Okay, everybody. We've only been going for about 5 minutes now. And I'm already seeing that this thing apparently, it's coded into the camera's firmware to look for about 2.2 volts as a cutoff. Our lithium cell here that's not doing so well is already down to, I'll get a good read of it. Already down to 2.57 or 2.56. And this thing here is just going away, recording away like it's got a full charge. I'm going to stop recording. That will decrease the load. We're up to 2.66. And we're going to go ahead and power down the camera. And that should go ahead and the battery voltage should recover up to about, we're at 3.2. Yes, that's a huge recovery, because this cell is just not doing so hot. Not at all. And for those curious, I have actually, in the past, I actually have checked to see how much current a Zi6 pulls. When it's recording, it pulls about, I want to say it pulls about 500 milliamps when recording. Probably about 600 milliamps when it's recording in 60 frames. We're at 3.3 volts now. Yeah, this thing is, this cell has shot up a huge amount. It's apparently there's a lot of internal resistance in the cell, or something's going on with this particular cell. It's just it's just wore out or something. It might have been one of the bad cells in that pack of batteries, but the other two just simply got really hot when trying to charge them. This one here just, I don't know, it's just gotten real weak. But, you know, when it's real weak, the voltage drops down enough to where theoretically the device should shut off to prevent any issue. So just for example here, I'm going to pop these two Panasonics out of the Play Touch and pop this cell in and see what the Play Touch thinks about it. Guarantee you it won't like it. There it is. Let's pop it into the Play Touch. Let's try power on the Play Touch, see what it thinks about it. See, Play Touch treats it as a dead battery. It's not even powering up for us. Now the Play Touch is very, very conservative about cutoff voltage on a lithium ion. You know, technically, you know, with my flashlights, you know, lithium ions, you can take them down to 3 volts or 2.9 volts, and you know that gives you a good long, you know, cycle of the battery. This thing here, the batteries have to be, it cuts off at least the resting voltage of the batteries when this thing finishes recording. You know, it cuts off due to low battery. The resting voltage of the batteries is like, let's see, 3.6. So I'm going to pop these back in. And you'll see, you'll start right up. See? And it says it has a full battery. Okay, so you're wondering, okay, is there still any way possible to get this to work on the Zi6? I say yes, there is. And you know why? You can use a silicon diode with a 0.7 volt voltage drop and drop the voltage that comes out of this by 0.7 to make this see a much lower voltage, because this here cuts off at about, you know, 2.4 volts is just for an example. It cuts off at about 2.4 volts, so 3.1 volts assumingly it would cut off if you added in, you know, something to drop the voltage by 0.7. Which, you know, 3.1 volts is a much better cutoff for a cell like this, you know, lithium ion. Well, okay, everybody, I think I figured out a solution to a problem. This here is a 1N4007 diode. It's actually commonly used in rectifying circuits. Our camera actually just shut off. But anyways, yeah, I'll show you here in a second. This is the little PCB to come off of. It's out of a desktop speaker, and there's actually 4 of them here. And of course, all you guys who watch my power supply videos should know what this here is. But if you don't, I'll go ahead and tell you. It's a bridge rectifier, full wave rectifier. It's actually not a bridge rectifier itself. It just mocks one. You know, with cheap power supplies, I would call this the 4 diode treatment. But you have 4 diodes there to make a full wave rectifier. This speaker essentially takes in power from a 12 volt power adapter that does not have rectification built into the power brick. It's just a 12. It's basically just a 120 volt to 12 volt transformer, and it actually rectifies. I'm sorry, I'm looking at the wrong thing. It rectifies the power inside here. So I took the 4 diodes out. Looked up a data sheet, and according to what they say online, I think the voltage drop of the 1N4007 is like, I think 0.9 volts, I think is what it said. Let's go look again just to be sure. But I think it was actually, let's see, 1N4007, 1 amp general purpose diode. Maximum instantaneous forward voltage drop maximum is 1.1, typical is 0.93 volts. Maximum full cycle, which is, it's like, an AC cycle, I believe is what it's referring to here. Maximum for that is 0.8. You get the idea. It looks like we're looking at a 0.9 volt voltage drop. So when your lithium ion 18650 is only doing 3 volts, the camera's seeing about 2.1 volts, and let's say if it was actually powered off of two AA's, that's generally what the voltage would be for. Okay, it'd be like, okay, I need to go and shut off because my batteries are dead. So essentially, it does not over discharge the lithium ion. And I actually have not heat shrink this yet. I just got it together. I got the heat shrink tubing over, just hadn't shrunk it down yet. Let's go and measure the voltage of our battery. Now the camera has in fact shut off. We're at a resting voltage of 3.4. Let's power the camera on. Okay, let me go ahead and set this up a little bit better. Now you can sort of see the best of both worlds, I guess. I'll try here. It'll be kind of hard to do both, but you can sort of see. You can see the multimeter. Okay, good enough. See if I can stick this in there to where we can get a consistent reading. Without damaging, of course, without damaging the little battery box. Battery box. I don't know about that. I just want to settle for just sticking the thing in there and see what we get. Okay, we're getting a voltage reading. I'm having to hold my finger on the other side, so I'm sorry about that. If we have any issues with reading. Man, this thing's hard to operate with one hand. I ain't the most crazy about the power on switch on a Zi6 or a DXG 567. Okay, power on. There you can see our voltage just dropped down to 3.9. I just unlatched the power button. I'm going to say no to set the date. And it says that our battery is at 3/4, but just watch what it does. Okay, we're at 3 volts, and the camera is saying the battery is about dead and we need to charge it. And if I press record, well, I guess I would go ahead and delete what's in the internal memory. Yes. What? It ain't liking something here. Apparently the battery's just getting too... Oh, there it goes. Okay, okay. Good. Delete. Yeah, this is all crap on internal memory. And if I go to record, it's already saying battery is flashing battery low. And it just shut off at 2.88. I think that's respectable enough. Because our resting voltage is already back up to 3.3. Let's try it again. Man, this thing's hard to get to. Dang it. Dang it, man. Camera's back on. Press record. Recording in standard. And I think it just dipped down to 2.7 there for a second. Which is a little low. But you know, for a second like that, I don't really foresee it being a problem. I think it's hard because the battery itself is, you know, it's already down to a pretty low voltage. So again, I'll do it again. No. Record. Bingo. So about 2.87. I think that's a pretty conservative number, you know, to shut off at. Because our resting voltage is back up to 3.3. How about we pop the Sony battery and see what it does then? I'm thinking, you know, when I have two in parallel, it may not dip as low. But, you know, 2.8 is not, it's not going to be the end of the world for a lithium ion cell. Heck, I think my flashlights, my flashlights had to start flashing the light to let you know it's about dead at about 2.9. So pop the Sony cell in. It has a lot more charge on it. I think it's about 3.7. And we'll do a similar thing. No, I don't want to set the date. And it says we have a full battery on the camera's display. Let's go ahead and meter the voltage at the battery itself. And get this to cooperate to be nice. Okay, so our Sony here is running at about 3.5. Let's press record. We're at 3.45, 3.46. Camera still says full battery, but you know, it's kind of beside the point. It's not properly metered for a lithium ion. The thing I care about, to be honest with you, is I just want to make sure that it shuts off when, you know, the voltage gets too low. So I think at this point what we're going to do, I know it's about 10 minutes in now, I'm going to go ahead and shrink this up. I'm going to take the camera, set back on the desk, let the sucker record. This thing may run for a really long freaking time. I mean, it really, I kid you not, I think it will run for an extremely long amount of time. Yeah, the biggest thing I was concerned about, of course, was making sure that it didn't over-discharge the battery. Okay, so I'm going to go ahead and get this prepped up and we'll continue on. Okay, everybody, here's our little test setup. This little battery here actually came out of one of my flashlights. It's that way, and I won't be sitting here all night waiting for the battery to discharge all the way down. This battery is resting at 3.48 volts. And we'll go ahead and power on the camera, just load in a memory card. One-handed operation here, trying to turn this thing on. We're at 3.35 volts. Again, we're working with a healthier battery this time. Additional load, we're down to 3.26. This is saying that we have 3/4 battery left. Let's go ahead and we're going to switch over to HC60 and start recording. We are now down at 3.15 volts, 3.13, and it's saying that we are low on battery, which is excellent. Now it's just a matter of a waiting game. To be honest with you. After seeing what this thing does, I'm going to call this the end of this part of the series, because next time I'm going to load in a fully charged 18650 and see how long the camera will go for. I mean fully charged from 4.2 volts, and we'll see how long we can get it out of a recording cycle. Hey everybody, I sure hope you guys enjoyed this video from Q Computer Channel. Remember to like the video, subscribe to Q Computer Channel for more updates, and remember to tick the bell so that we actually get notified of these updates. Did you know that I am also on a second channel that's Bike Geek MTDX? Over there you'll find videos of bicycling, weather, elevators, and all sorts of other neat and interesting stuff. Feel free to subscribe to that channel as well. And again, I thank you for your support, and thanks for watching this video.